Physics, Part 306. Isaac Newton concluded that the Earth's force of gravity is also responsible for keeping the Moon in orbit. His calculations showed that the Earth's force of gravity extends into space but weakens with the distance according to an inverse scale law. That is, the Earth's force of gravity varies inversely with the scale of the distance from the center of the Earth. If you go 2 Earth's radii from the Earth's surface, the force is a quarter of the force on Earth's surface. This is part of Newton's law of gravitation. Newton's law of gravitation states that 2 points' masses attract each other with a force that is proportional to the product of their masses and inversely proportional to the square of their separation. Hence, if F is the force of attraction between the two bodies of mass m1 and m2, respectively with the distance r between their centers, then F omega m1 m2 over r square, or F is equal to g m1 m2 divided by r square, where the constant of the proportionality g is called the gravitational constant. The value of g is 6.67 into 10 raised to minus 11 nm square kg minus 2. Notice that the equation has a similar form to that of the Coulomb's law between two charges. Both Newton's law and Coulomb's laws are inverse square of laws for force. We say that the equations are analogues, or that is, there is an analogy between the aspects of electric fields and gravitational field. However, there are important differences. The electric force acts on the charges, whereas the gravitational force acts on the masses. The electric force can be attractive or repulsive, depending on the signs of interacting charges, whereas two masses always attract each other. It is possible to measure the gravitational constant g in a school laboratory, but the force of gravity between the laboratory-sized masses is so small that it is not easy to obtain an accurate result. Gravitational field strength. The gravitational field strength is a point. The gravitational field strength at a point is defined as the force per unit mass acting on a small mass placed at that point. This continues the analogy between the electric and gravitational fields. Remember that electric field strength is defined as the force per unit positive charge. The force per unit mass is a measure of the acceleration of free fall by Newton's second law of motion, F is equal to ma. Thus, the gravitational field strength is given by F is over m equal to g, where F is in newtons and mass is in kilograms. This means that the gravitational field strength at the Earth's surface is about